Okay, let's take a quick look at the sum and difference identity or formula for the sine, cosine, and tangent. So if it's a sine of a sum, what we're looking at is the sine of a sum of angles. I'll call it angle A and angle B. And then we want sum or difference, right? So I'm going to say sum or difference. We're going to write two formulas or two identities as one. I like to think of the sine of a sum as a same sign sandwich. Okay, that's just a memorization technique, something that helps us remember what's going on here. So a sine sandwich is actually a cosine sandwich on sine bread. So we go sine of the first angle times cosine of the second angle, and watch the plus or minus. It's the same sign. So if you're taking the sine of a sum, it's still a sum. If you're taking a sine of a difference, A minus B, it's a difference here. So they follow the same pattern. So sine of the first, cosine of the second, plus or minus cosine of the first times sine of the second. And this is where that memorization technique comes in. Notice you have sine on the outside and cosines on the inside. Always angle, first angle, second angle, first angle, second angle. The sine of a sum or difference is the same sign. If it's plus, if you're adding two angles, you're finding the sum of the angles, it's the sum of those terms. If it's a difference of angles, it's the difference of the terms. So that pattern follows through. For cosine, if you're doing cosine of a sum or difference, so we're gonna use a similar stuff here. A for the first angle, B for the second angle. We'll put a plus or a minus. Again, we're putting two formulas or two identities in one. Now, cosine is not a sandwich. It's not the same sign. So if you can remember that sine is the same sign sandwich, the cosine's the one that acts differently. So what we do is the cosine of the first angle times the cosine of the second angle. Now this one, watch this, it's actually the opposite. So if you were taking a sum here, it's now a difference when you're expanding and using that formula. And if it's cosine, cosine, now it's sine of the first, sine of the second. Okay, so these are two different formulas, sine of a sum or difference, cosine of a sum or difference. But we're looking at the patterns here. Again, these are not proofs. I'm just giving you the identities or the formulas, and then I'll show you how to use each of those. Tangent of a sum or difference. And again, I'm going to try to help you out here in terms of using color to show what's going on and explain. Again, it's not so much the why as it is just tricks to remembering them. So cosine of a sum or difference, we're using A for the first angle again and B for the second angle. Think about this. If it was sine, it would be the same sign. So since tangent has sine in the numerator, I like to just put the same sign in the numerator. In the denominator, it'll be opposite. So notice, tangent of a sum is still a sum on top. In the denominator, tangent of a sum becomes a difference. So the only other part to look at is, okay, what goes in here? So you'll have the tangent of the first angle. If it was plus in the beginning, it's plus up here when you expand that formula, plus the tangent of the second angle. And in the denominator, we'll have 1 minus or plus tangent of the first times tangent of the second. Example, if I wanted to find, you ready for this? Sine of 5 pi over 12. I have no idea what that is because 5 pi over 12 is not a special angle. It's not. So what I'm going to try to do, I'm going to do a little scrap work here. I'm going to go, okay, wait a second. I've got 5 pi over 12. Can I write 5 pi over 12? This is my scrap work, right? 5 pi over 12 as a sum or a difference. So I'm just trying to come up, okay, things that add to 5. And the ideal situation here, again, I'm kind of just spitballing here, trying to figure some things out. 1 and 4 is 12. 2 and 3 is 12, or 5. Sorry, 1 and 4 is 5. 2 and 3 is 5. Those are really my only options. And I'm kind of cheating here. I'm saying, look, I know 2 pi over 12 reduces to a special angle. So does 3 pi over 12. Okay, so what I've done is I've chosen to unsimplify 5 pi over 12. And the reason for that is I know that this angle is pi over 6, right? 2 pi over 12 is pi over 6. And 3 pi over 12 is pi over 4. So that's like that scrap work. Most of the time you're not going to write this out. That's, it's the first time you're seeing these. I want it to be clear why I'm doing what I'm doing here. So what I'm going to say now is, okay, look, I've got this way to write sine of 5 pi over 12. That's a little nicer in terms of using my sum or difference identity. So I can write 5 pi over 12 as pi over 6 plus pi over 4. And if you're not sure why, like if you skip to this point, this comes from my scrap work. I'm trying to write 5 pi over 12 with special angles. And now I can use my sine of a sum identity. So I can say this should be equal to the sine of the first times the cosine of the second. I'm going to just write it like this for now. Plus, because it's the same sign, cosine of the first, sine of the second. So now I'm going to fill in those angles. Sine of the first. Right, we go first, second, cosine of the second, cosine of the first, sine of the second. So I can now say, all right, let me do this, right? Sine of pi over 6 is just 1/2. Cosine of pi over 4 is root 2 over 2. Cosine of pi over 6, root 3 over 2. And sine of pi over 4, root 2 over 2. So what I'm doing is I'm figuring out an exact expression for sine of 5 pi over 12. This would be root 2 over 4 plus root 6 over 4. And if we want to simplify even further, we can say root 2 plus root 6 all over 4. So what we've done is we've come up with an exact answer for sine of 5 pi over 12, even though 5 pi over 12 was not a special angle.